Alright. Hope this works out.
So
Okay. It's gonna be weird in film. Oh well. It's gonna get over it.
Do you have any of his books?
I don't know.
'Cause I don't take a single book home when I go like
Right. I'm gonna. Well, I'm saving lecture notes and stuff. And luckily, you don't need the book necessarily. That's the nice thing about math sometimes. The book has the problems in it, but those can always scared. It is what would be. All right, let's start by looking at some of those homework problems from last night, and kind of concentrate on how those work before we move on. Okay. So the first set, okay, on 57 through 59, those first three problems, those were just about setting those things up, okay? So I'm going to do 57 up here on the board, and then I want volunteers to do 58, 59, because this is sort of a thing that's really the type of thing that works more hands-on than anything else. If that makes sense to anybody. All right, so all we're doing here with a problem like 57, okay, is we're going to set up the partial fraction decomposition . But not solve it. Okay? So, what exactly we mean by that when we do these sorts of things is that we're going to just take the thing and we're going to break it apart into whatever fractions or again, leaving the numerators as A, B, C, etc. Okay? So this very first one, 57, we have 7 over x squared minus 14x. Okay. So, when setting these things up, what do I have to do to start off with?
simple.
I have to
Take out the x.
factor, basically factor or simplify. Well, factoring and simplifying are the same thing. Sorry, did you say factor in the back like twice and I didn't hear it? My bad. Okay. So, basically, we're going to go ahead and do that by taking out the x, okay, down here, because that's what we can get out of here. So this would become 7 over x times x minus 14, okay? Any questions about how that works? Pretty straightforward factoring, right? All right, now what do? Basically, we split it into two fractions. This is going to be a over x plus b over x minus 14. And that's as far as we need to go with these problems, okay? When we're doing a setup, all right? So we're done at that point, okay? The idea is just to do the sum, because at this point here, solving for a and b could be easy, would be fairly easy to do. All right, can I get a volunteer to do 58? Anybody? All right, come on up.
Patrick,
All right, everyone, pay attention. See if you do the same thing. Okay, close. Okay, you actually have the right idea down, exactly how to split this thing up. The only thing is, you're factoring. Look very carefully there.
4 times negative 1 equals -3.
You did your factoring backwards. That's all right though. Okay, because that's easy enough to change. And this is the sort of thing that's you know, the actual process you did fine. It was just the math at the end. Easy enough to this. So you're on the right track though. It goes x plus 1, x plus 3 is what it factors to. And then there we go, yeah. So make sure when you factor things. But otherwise, perfectly fine. Everyone get the idea there. Okay. Again, these are some of the more simple problems, just trying to get used to how these things work. Alright, can I get a volunteer for 59? Oh, don't everyone jump up at once.
How you guys I'll take it.
Alright, thank you. Let's see. What's this chair do across class? Let's take this chair in the corner. I'm not sure if I did that or not.
Yeah, don't do
This one, was it that one or that one?
I use that one.
it. That one.
Oh well.
Nothing's.
Okay. Is that look correct, everybody? Is that what everyone else has? Well, good. If you had this, you were correct. This is exactly how it should break apart. Okay. Notice here, x squared. Okay, when you factor out the x squared here, sometimes it's nice just to write beneath hand what the two factors end up being. X squared is going to work no differently than any other linear factor. Okay. Because it's x times x, it has to be repeated in the problem, which is why it's a over x plus b over x squared plus c over x minus 10. Alright, good. Okay, now before we jump on to the next set of problems, even though the directions for the set just said to break them apart, let's go ahead and actually work out what the answers are for these last three. There's another reason why I gave them all their separate pages here. The smartboard, nice. Love it. Alright.
Smartboard.
Actually, I hate the smartboard. Anyway, we'll go ahead and go ahead and work out this one right here. So, when fixing it out, there's a little trick, basically, to work out the next step a lot faster than having to, say, multiply everything out by hand. The way these things work is, whatever letter you're solving for, you're always going to want to put every other denominator next to it, basically. Okay. The only time it doesn't work necessarily is when there's a repeating factor, and then it's just a matter of where we are in that repeating cycle, and I'll show you when we get to that one here. So this one though is fairly straightforward. To solve for a and b, we're just going to simply write this as 7 equals a. The denominator opposite of a would be x minus 14. Okay. Plus b. Other denominator is x, okay? If there was a c, we would put c's denominator next to a and b as well, basically. And vice versa for all the rest. So it's just kind of a trick to kind of speed these up. Alright, let's make that look more like a 14. Alright, good. So, at this point here, what do? How do we normally solve these things? We do what?
Put something for x.
Yeah, we choose the x, plug it in this thing, and then solve for a and b using that. And the idea here, the trick is to choose an x that gets rid of most of the terms here.
0.
So 0 is by far the easiest one to choose. That's going to get rid of b immediately. So when x is equal to 0, okay, I'm going to have 7 equals a times negative 14, and b drops away. So that gives me 7 over negative 14 equals a, which means A then is what? Yep, A should be just negative 1/2. Okay, good. Now, what next should I pick for x? 14 would be the easiest thing to pick. Okay. At this point, though, because we know what A is, I can technically pick whatever I want x to be, because I can then substitute negative 1/2 in for A. Okay. But it's best to pick an x that just gets rid of it entirely. So 14 will do that. So we'll pick x to be 14. That gives me 7 equals, that cancels away, so it would be b times 14. Well, that was fairly easy, right? That means b is 7 over 14, which means that b is 1/2. Okay? Any questions there? All right. Now, we got fractional answers for what a and b are, which is fine, by the way. You can get fractions; those don't matter. But when we record our final answer, you know how we always want to write out, you know, a basically the number that a was over whatever our fraction was. So we should have basically negative 1/2 over x plus 1/2 over x minus 14 equals what we started with, which was what, 7 over. Okay. With these fractions, it's customary to go ahead and actually clean up the answers when you plug these numbers in. Okay. So oftentimes, and this will be certainly the case in the back of the book if you were to look up an answer, you won't see it written as negative 1/2 over x, but instead as negative 1 over 2x. Anytime you have a fraction, you can just accordion it down, if you will. Okay? So this one over here, the 2 here is going to multiply both the x and the negative 14. So we'd write that as 1 over 2x minus 28. About the rate plus 28. Okay, so a lot of times with these things, you'll see the answers down here like this instead of like that. Okay? As far as, you know, kind of, is this something you really necessarily need to worry about? The point of doing these things is to basically make it so that way if I were to add these two fractions together, I'd get back to what I originally had. Okay? And it's actually a little bit easier to add these together to get this than it is to add these together to get this. And the reason is simply because if we were to add these together, we would instantly see that 2 factored out and we just cancel out, leaving us with 7 over x squared minus 14x. While if we try to add it when it's like these two right here, we're going to run into the issue of dealing with that 1/2 in the numerator, and it kind of gets annoying quickly, basically. So I encourage you all, now I probably wouldn't take off for this if you left it as this up here initially. Oops, what did I just do?
Undo.
Where did we go?
Undo.
Undo?
Again.
There we go. Alright. I want you guys to start fixing it so it's like the accordion version down here. Okay? Everyone got that? It's an extra step, but this is one of the few cases where simplifying an answer is actually important in the long run. Okay? Everyone got that? Alright, good. Alright. Let's see here. I'm going to move all this up here. Alright. Volunteer to take this one and solve for A and B. Okay? Anybody interested? You keep volunteering, Pat.
I'll go.
Okay, come on up and take a go at it. Alright? Put it this way, everyone at some point is going to get a chance up here. Maybe not everybody today, but...
Stage fright. But this is what I was confused about. Like, if it's... If you put, you know, negative 1 there, it just is... It's undefined. So is that...
Okay. Right now, if you put negative 1 in, yes, it's undefined.
Yeah.
But the idea is to solve for A and B, okay, later on. The thing is, we're gonna get rid of these denominators when we do that multiplication trick.
Okay,
And so that's what we're gonna have, so it should be x minus 2 equals